everyone, and welcome to this Nokia webinar, AI ML Use Case Results in 5G Packet Core Networks. Today we'll explore how AI and ML transform data into predictions and automated decisions, driving efficiency and innovation across 5G Packet Core Networks. In telecom, these capabilities power real use cases: anomaly detection across networks and services, root cause analysis to accelerate troubleshooting, predictive maintenance to reduce downtime, and load demand and traffic forecasting to optimize capacity. My name is Shelley Schluter, and I will be your host today. It is such a pleasure to have three experts in the field of AI, ML, and telecom industry join us for a discussion on the transformative power of AI and ML. Ruth Brown, Principal Analyst for Mobile Networks at Omdia, is our first guest. Her key coverage areas include system architecture, core infrastructure and services, and supporting cloud technologies. We also have Gordon Milliken, Head of Packet Core Product Management at Nokia. Gordon brings extensive experience in the design and implementation of cloud-native network solutions, and he will be sharing insights into the architecture and capabilities of Nokia Cloud Packet Core. Our third guest today is Mrinmoy Bhattacharjee, Principal AI and ML Software Architect at Nokia. Since 2019, he has conceived from the ground up an entire AI ML solution for Nokia Cloud Mobility Manager. Together, these experts will provide a comprehensive overview of this innovative solution and its impact on the future of telecom networks. Our chat window is open for live questions, and if we can't answer them during our discussion, we'll send you the answers after we're done. So let's go ahead and get started. Hello, everyone. Ruth, I'm going to start with you first. AI has clearly moved beyond the hype phase. We're seeing substantial investments flowing into both AI development and the critical infrastructure needed to support these technologies. Simultaneously, real-world AI applications are gaining widespread adoption across enterprises and consumer markets, delivering impressive results. Given this landscape, I'd like to hear your perspective on AI and ML's role in the telecommunications sector. What key trends are you observing, and what expectations do you see among communications service providers?
Well, thanks very much, Shelley. It's great to be joining you here today. So certainly there's quite a lot to unpack with that question. There's been significant hype, as you mentioned, but now AI is really a sort of core component in most industries, including telecoms. So in terms of, what's happening in the industry, so AI investment and activity, we're seeing several trends already. So firstly, there's a demand for AI-ready infrastructure, and this is to support more data processing and the machine learning. We're also seeing that operators are investing across data centers, cloud, edge compute, as well as deploying specialized hardware. So things such as GPU, AI accelerators, new silicon, and these are all to enhance the performance. So also with this influx of AI and new services that we're hearing about, operators are wanting to build readiness and leverage AI itself, so AI for networks, really to optimize the customer experience and the performance that their customers are receiving. So firstly, if we look at the slide, I think there's three major trends here. So data quality remains critical, but as we see advancing AI technologies, it's really driving an even more critical and a deeper focus on addressing, firstly, the vast volumes of data so we can actually get the information about the network, also ensuring that it's accurate, ensuring it's consolidated and compliant. And really, this is all going to help AI decision-making to be accurate and to be, worthwhile using the technology. Next, we're seeing traditional monitoring systems are evolving. You mentioned in your introduction about kind of more predictiveness. So we're seeing predictive observability tools tools that are able to anticipate issues before we're seeing major impacts. So these include the items you mentioned, sort of predictive analysis, diagnostic tools for detecting anomalies, predicting failures, and also enabling this much more proactive remediation. Another point that they can also support is this hyper personalization and dynamic querying. So allowing to make faster decisions and make more personalized experiences for customers. Thirdly, we're seeing much more focus on increasing levels of autonomy, trying to keep pace with these new services, trying to manage, the complexity that we're adding into the networks to give us these amazing new services. So really operators moving from this manual or semi-manual operations activity to manage their network towards fully autonomous networks that self-diagnose and heal. So, we're not there yet. I think many operators are still in the early phases. This automation, it's kind of a longer term phase. TM Forum, levels 2 to 3 are where most of our operators are right now. So that's the sort of partial to conditional autonomy network ability levels. But really, they want to work to become much more advanced and add in these new capabilities. So I spoke about AI, and we're seeing AI evolve really rapidly. It's one of the fastest moving technologies we've seen probably to date. So we're seeing AI moving to be much more sophisticated. The industry is already utilizing and growing confidence with predictive AI and ML. We're seeing sort of generative AI and large language models coming in. But now we need to learn how to introduce more advanced AI technologies and build trust. So introducing things like AI agents, multi-agent systems that are going to take us to a next phase that's able to sort of think, plan, execute, and then reflect on their actions. So these need much less human interaction and support. So these cognitive systems really are going to enable the next generation of informed decisions. They can do complex scenarios, and they're going to be able to achieve this kind of increased operational efficiency, improve customer experience, and also, maybe new revenue generation, finding new streams through being able to understand and recommend things for customers.
Wonderful. Thank you so much. So Gordon, now we're going to move to you. We introduced AI ML capabilities to our cloud packet core solution around 2022. What was the main driver for such early implementation of this technology?
Hi, Shelley. First of all, let me thank you for giving me a chance to talk about this exciting technology. Historically, telecom networks have been designed to be pretty rigid, over-dimensioned, dimensioned for peak traffic and running 24/7 at that level, while in reality, demand is both seasonal and bursty. And for that matter, our response to network behavior and applications is to simply send data northbound for people to make decisions about how to affect network behavior. In our Packet Core Cloud Mobility Manager, CMM, which handles the control plane for Packet Core, we've embedded a real-time AI ML engine to be able to address optimization of the network and manage dynamic behavior of the network at the local level. There's certainly a place for, and we'll be talking in future about AI ML across the core and across the entire network. But here we're focused on the optimization that you can achieve with localized AI ML embedded within applications. One use case is to be able to anticipate demand and shift capacity intelligently, turning static engineering into an adaptive operation. Anomaly handling moves from reactive, threshold-based interventions to proactive detection and automated mitigation, which protects SLAs and reduces congestion and outages. End user reachability improves network performance by predicting mobility and paging conditions so that the first attempt to connect to users succeeds more often, giving better user experience. Root cause analysis becomes a low-touch, data-driven workflow instead of a series of humans toiling away at disparate data for hours and hours, trying to make sense of the complexity of that data. CMM correlates multiple telemetry streams like its event-based data collector, we call PCMD, KPI counters, alarms, and log information across every radio access type, so 2G, 3G, 4G, 5G, and pinpoints likely causes and recommends or executes safe actions. That same local analytics hardens security by spotting unusual access, traffic surges, or denial of service patterns and responding in near real time, and during disaster recovery, policy-driven protections preventing temporary topologies from becoming new attack surfaces. Success is tracked with KPIs that matter to the business: registration and session establishment success rates, paging success rates, mean session setup time, slice level throughput and latency, congestion and anomaly rates, and operational mean time to repair. Our initial use case of using of AI ML in our local system was predictive call load, which for operators deployed on hyperscalers could be used to scale the CMM footprint in to save on expensive compute resources. When we discussed this with some of our major customers like Orange in France, feedback was, hey, I won't be deploying on hyperscalers, but can we adapt this technology to scale in to reduce power draw on the infrastructure, providing more powerful ways to use this technology? One of our latest use cases addressing paging, where the efficiency and speed of finding the UE has a big impact on consumer experience. The faster the call can be established, the less likely consumers will be to give up and end call attempts. Our key North American customer, T-Mobile US, has been able to achieve best-in-class call performance using our advanced paging algorithms and is trialing our AI methodology as we speak.
Very exciting, and I can see why they would have wanted this early on. All right, Mrinmoy, now we're going to go to you. Can you give us an overview of the Nokia implementation of AI and ML on Packet Core and the main use cases we have available now?
Sally, thank you very much for giving me the opportunity. So one of the major things that we have is called the Machine Learning Intelligence Service Pod, and which is the backbone of AI/ML operations in the Cloud Mobility Manager, the CMM, and it's designed to perform a number of things. It's designed to perform data streaming. It actually becomes a local data lake, and we have already, we have talked about, data lakes, which are big data lakes for analytics, enterprise level, but we also have a local data lake here inside the MLIS. And then the MLIS performs model training, and then it also performs model inference, and which is also called serving. So the MLIS securely transports AI/ML data from multiple CMM pods. We have different pods inside the CMM, and it pre-processes the data and then converts them to custom matrix that drive intelligent decisions. And in order for us to ensure robust data management, the process data are actually persisted. It's very important for any AI/ML to persist data for a long amount of time. For historical reasons, one can go back and check, whether the decisions are correct or not. And also on top of that, we have technology that actually can stream this data northbound to, bigger data lakes for broader analytics. Operationally, the MLIS basically orchestrates the full AI life cycle inside the CMM. It starts from collecting data from CMM entities, preparing them for model consumption, scheduling both model training and serving, and coordinating with CMM components to trigger AI/ML-driven serving actions, mitigations when needed. Model training is one of the most compute-intensive works in AI/ML, as a result of which we have, built technologies so that we can actually run this model training in ephemeral pods. And, these ephemeral pods, the trainings can take anywhere between few minutes to up to 12 hours, depending on the use case. And once the training is completed, the published models, all the log files, the artifacts, all of that is handed off to the MLIS. And then the ephemeral pods, basically, the ephemeral pods gracefully terminate. And all production model serving is centralized inside this MLIS pod, which also offers northbound streaming to data lakes to support enterprise-grade analytics pipelines. Now, I would say telecom networks, as Gordon stated, are very intricate. They're dynamic systems, and our AI/ML portfolio is designed to turn this complexity into predictable and manageable behavior. Challenges that telecom network faces, we provide a variety of AI/ML solutions that are value adds on top of 3GPP standards. And the solutions that we have now and those that will become available soon can be categorized as follows. Traffic load prediction. Any telecom network or system can benefit from these predictions in order to perform compute resource scaling to save cost and power and scale out before traffic surges to avoid congestion and outage. Another thing is anomaly detection and mitigation. And one example that we have is dialing down UV finding activity only to areas of the radio network which are experiencing anomalous situations. Third, we have the UV location forecasting model to find UVs in the first attempt. And the whole idea is to reduce call setup time and to reduce network signaling load. Intelligence admittance control during disaster recovery scenarios, and then intelligent load distribution after the disaster recovery is complete. Those are another set of use cases we have. Root cause analysis for various call failures. They are currently embedded inside the CMM, and we are also working on sophisticated agentic approach that will use large language models using northbound stream data. And another thing that bothers a lot of our operators are denial of service attacks, and we have built AI/ML models for the detection and mitigation. So these are our current examples, and we have more use cases that will be added in the future. And moreover, the design of this MLIS pod is such that the AI/ML will be added inside the CMM can be extracted, the software and the techniques can be extracted, and they can be extended to other areas like IMS, UDM for use cases specific to those areas.
That's an exciting lot of use cases. Thank you so much. All right, Ruth, I'm going to come back to you, and we're going to talk a little bit about the future. So while AI is already making significant contributions to core networks, there's substantial room for advancement. What's your perspective on AI/ML integration within 5G networks? And from a CSP standpoint, which areas do you believe should be prioritized to maximize the benefits of AI/ML implementation?
Yeah, absolutely. And on a build on the themes, obviously, that I spoke about earlier, and, Gordon and I brought up some great points when they both spoke. So if we sort of move closer to home to the 5G core and its network functions, really, they contain this huge wealth of network data. So this creates really good opportunities to embed intelligence, to embed, greater amounts of automation to the heart of the 5G core. So allowing it to transform the way we manage things such as sort of access. So, being aware of things perhaps like a signaling storm, which we would have been reactive on in the past, getting smarter about mobility management, policy functions, and also optimizing experience, moving from these kind of very static huge over-spec'd networks to ones which are able to kind of adjust and flux and scale in and scale out based on demand. And this is much more energy efficient, as both Gordon and Mimoy actually spoke about earlier. If we look at really about how AI is going to be integrated and also the adoption and prioritization of use cases, I think it's first sort of important almost to look at the way in which it will be adopted. So over 60% of operators really expect to start adopting these use cases, but starting with open loop autonomy for network tasks. And this is within the next 18 months. So within that group as well, 25%, are keen to transition these key functions, such as the poor performance optimization, energy efficiency, towards closed loop autonomy. This is within the same time frame. But obviously, these are quite ambitious. These also need to be able to build the levels of trust. And I think this is why, the 60% are talking about this open loop or having a sort of human oversight for accuracy for a while. Moving closer to home, if we look, at the use cases in a little bit more detail, obviously network optimization is going to be a real key use case. So being able to leverage, core network function data to deliver these performance improvements. So being able to reduce latency, being able to, Mimoy spoke about it, being able to manage mobility better, knowing, where your user might be perhaps moving to based on this kind of historical data that you might be building up. Also, this proactive ability to optimize your network. I sort of spoke about in the past, networks are very large and, over provisioned. Being able to scale based on predictive learnings of traffic demands that you've learned with, and to basically allocate resources as and when you need them. Customer experience, obviously, this is going to be a massive area. Operators are already sort of moving AI into these customer experience use cases, really to understand network behavior better, but also how service degradation might affect their customers. So being able to track historic conditions, look at customers' policies, and kind of more intelligently upgrade, ensure their experience doesn't degrade. So we're ensuring we're keeping hold of our customers, we're reducing churn by, intelligently using this. And this is a very important use case. It also, within this kind of whole use case of AI integration, the more you know about a customer, the more you know about their kind of subscriber experience, it allows you to add more personalization. And these are all things that we can get the information through our sort of core network. Lastly, sort of troubleshooting, obviously a major area. We know that AI, machine learning, is really good at sort of sorting through large sets of data. It can do it really quickly. It's good at sort of detecting and resolving anomalies, understanding the historical patterns that I spoke about, and also using these to kind of predict future failures perhaps in the network. So, I believe, operators do recognize this major impact that AI is having. They're already putting focus on how do we integrate AI closer into the core network? How do we use it alongside our analytics, functions like the NWDAF? How do we kind of enrich and make our network smarter? If we look forward really towards 6G and sort of new generation architectures, these are going to be much more closely linked with AI and to the core data architectures. Already we're seeing in 3GPP standards bodies initiating discussions really about how they integrate some of these advanced AI technologies. So not just predictive AI or generative AI, but how do they start integrating agentic AI really to achieve this kind of cross-layer data collection and management within a kind of standardized framework. So we can use this to enrich the experiences our customers receiving, but also to be more efficient with energy costs and just be a more optimized and better performance through our core.
Okay, so AI is going to be critical as we go forward into new technologies getting closer and closer together. All right. Well, Gordon, now I'm going to move to you. How is Nokia developing and advancing our solutions to address evolving CSP demands, and what is the vision for the future?
Well, Shelley, I'm going to be a little bold here, perhaps. In simple terms, our vision is an AI native, increasingly autonomous core that shifts from automating tasks to automating outcomes. So I think a lot of what Ruth talked about is coming, and the philosophies that 6G is built on are things that we want to begin integrating into our networks today. So far in this session, we've been talking about local AI/ML in individual nodes, like anomaly detection around AMF and MME, but also things like cognitive autoscaling for UPF or traffic steering for slices. We're expanding beyond that into a layered approach. AI embedded directly into core CNFs for fast local decisions, like we've just talked about. Domain level intelligence across packet core entities for resource optimization and root cause analysis, and cross-domain analytics that connect networks, services, and subscriber data to drive closed-loop alignment with business intent. So think things like NWDAF, MDAF, plus assurance, all working together. Looking forward, the big step change is agentic AI. Instead of relying only on standalone LLMs or dashboards, we're building AI agents that are grounded in telecom domain knowledge using shared context, for example, model context protocol, knowledge graphs, and well-documented data models to execute operational intents safely and transparently. These agents will plan configurations, assist deployments, monitor and detect issues in real time, and trigger mitigations across multi-vendor and multi-cloud environments. Tools like our GitOps-based lifecycle management tool, NCOM Evo, core monitoring and troubleshooting tools like NCMT, and Nokia Assurance Center form the operational fabric that lets us scale this automation without losing control or explainability. So, what does that translate to in real life? More first attempt reachability by predicting mobility and paging conditions, cognitive scaling that prevents overloads before they become outages, slice assurance that continuously optimizes throughput and latency against SLAs, automated anomaly and denial of service mitigation with explainable remediation paths, and faster mean time to repair thanks to AI-guided RCA that correlates per call data, counters, and telemetry across the core. The destination is an L4, L5 autonomous packet core where operators express intent and trustworthy AI agents deliver resilient performance, efficiency, and security, ready for 5G advanced and paving the way to 6G.
So exciting to see that augmentation coming to life for people working in that space. Right, Mrinloy, what AI ML use cases are we currently developing? And in which operational areas will these use cases deliver value for CSPs? Are there any specific benefits we're targeting?
Shall we continuing on base of what Ruth and Gordon just said? I just want to repeat one thing, that these networks are very intricate and dynamic. And one of the key things here is that each of these networks serve millions of end users. And as a result of which, the AI models that are in our portfolio, they're designed to turn this complexity into predictable and manageable behavior. So I'll talk about a couple of very interesting use cases that we are working on, and we are partnering with our customers to trial them also. So one of our standout use case is AI/ML-based UV location forecasting, where the AMF, the Access Mobility Management Function, it provides periodic location updates for a subset of UEs. And then we recycle the UEs so that we can actually create a knowledge graph here. And by learning the movement patterns over multiple days, I mean, it takes about a week for us to create a very intelligent geo map of the UEs as they travel through the radio network. And then once we have this model, when we apply this model to previously unseen UEs, the forecaster, it will use the last 4 to 5 genome location points of the UE, the time date, because as the time progresses, the movement pattern of the UEs in the radio network, they change. So time date is very important. And then we use our learned geo map to mobility map in the deployment, specifically in the deployment. And why talk about deployment? Because different deployments have different movement patterns. Now, operationally, how does it work? Right? Operationally, these predictions are fed to the packet core's paging and reachability logic. So the system narrows the search area to a focused set of GDOBs rather than broadcasting widely. You don't want to reach out to hundreds of GDOBs to find one UE, but you want to intelligently find some candidate UEs, and then you actually search for the UE in that location. And the result is it basically cuts down on what we call paging fan out. And, in realistic lab testing with very intelligent call models, we have seen at least 50% reduction in paging fan out. And this reduces signaling load, shortens the time to reach the user device, and it directly lowers network congestion during busy periods. But in practice, the model's output is integrated to packet core's paging policies so that the network connects proactively rather than reactively. For example, during peak hours or in dense urban hotspots, the forecaster, it basically anticipates where the UEs are likely to be, and it constrains the paging to those cells only in those areas. This directly improves reachability, provides first attempt success rate, a very, very big improvement in first attempt success rate. And, since you can reach the UE in the first attempt, call setup is very fast. Now, let me talk quickly about additionally, if you can include, and we have included anomaly detection capabilities with this traffic forecasting, operators can simultaneously reduce unnecessary signaling and assure capacity where it matters. So we have a general paging anomaly detection model that detects anomalies in the radio network. And then we have a localized paging anomaly detection model that allows the packet core to restrict paging activity in anomalous regions. Other things that we are working on are disaster recovery scenarios, where you have a disaster and you have a recovery core and UEs are showing up with a big spike. And you really want predictable models there which can perform admittance control, because you don't want the recovery core to go down. And then the other set of things that we have been working on in partnership with some of our customers is denial of service detection and mitigation. So, based off, the model outputs that we have, we can also provide visuals, and that show how the trajectory-aware paging trims the search area, accelerates the UE contact, and eases packet core and radio network load. So by fusing the trajectory model with packet core control loops and deploying it through MLS pod, operators can gain practical end-to-end mechanisms to improve reachability and overall network efficiency. And as our AI/ML capabilities evolve, the MLS pod will continue to be the engine that will industrialize these models, scaling them across regions, keeping them calibrated, and extending them to new mobility behaviors and service contexts.
Excellent. Thank you so much for explaining that, Mrinmoy.
Thank you.
As we approach the end of our webinar, we've covered a lot of ground today. We've explored the market expectations for high performance, energy efficient networks, and how Nokia Cloud Packet Core is delivering on those expectations. Now, I'd like to invite our participants to share their final thoughts on the future of cloud networking and the role of this innovative solution in shaping the telecom landscape. So, Gordon, let's start with your final considerations, please.
Okay, summing up, Nokia aims to make the packet core and the broader end-to-end core AI native and increasingly autonomous, moving from automating individual tasks to automating business outcomes. Intelligence is layered, embedded in core CNFs like AMF, SMF, UPF for quick local decisions, across the core domain for correlating telemetry and optimizing resources, and across domain via NWDAF, MDAF, and assurance to drive closed-loop service and slice performance. The next step is agentic AI, telecom-aware AI agents that plan, deploy, monitor, and safely remediate across multi-vendor, multi-cloud environments.
Thank you. Rinmoy, what thoughts would you like to leave the audience with?
Yeah, there are many thoughts and many opportunities, but I'd like to focus on this current model that we are working on because it's really exciting because it brings in or gives a lot of savings, be it power, be it wastage of, and not just the transport bandwidth, but also the over-the-air bandwidth and end user experience. So in closing, I'd like to say the focus on the trajectory error paging model that we are working on. It is powered by the AMF-driven models and deployed through the MLS pod. It consistently narrows the search area, reducing signaling, and accelerates first page success. And our lab results show predicted UV locations closely tracking actual movement and strong precision across location buckets, and measurable reduction in paging fan-out and time to reach, confirming both technical accuracy and operational impact. And these models evolve. As these models evolve, MLS ensures scalable deployment, continuous monitoring, and rapid retraining, turning complex mobility data into actionable network-wide performance gains.
Thank you so much. And Ruth, is there something you'd like to reinforce for our audience?
Yeah, absolutely. Thanks, Shelley. I think really, we're all very aware, operators are very aware that they want experiences to be driven by, the customer. They want to be able to back up, a great experience, be able to protect their performance. But really, this is going to mean working in a different way. It's going to mean using more of our network data in the core, using it more smartly. So building things like these knowledge graphs that we're able to kind of use historical data and then process it via AI to give us better experiences. It's also going to be us using and learning to use these new, much more advanced mechanisms. So trying to move towards these kind of new agent-based systems, which are, starting to come in. But really behind all of this is going to be us, starting to build up trust in them. So there is a bit of a journey, to be able to build up these foundations from this kind of semi-autonomous layer to this kind of fully autonomous operations. But already, we're using, predictive AI very successfully, generative AI very successfully. And we just need to continue the progress, just building it up and then reap these rewards, these more efficient energy savings that we're able to use by, scaling our core network as and when we need it for demand and being able to, find and troubleshoot issues much quicker so we're not affecting any of our customers.
Wonderful. Well, thank you to Ruth, Gordon, and Rinmoy for your insightful perspectives and meaningful contributions today. We hope this webinar has provided you with valuable insights and a deeper understanding of the AI ML technology driving the next generation of telecom networks. We encourage you to continue exploring the possibilities of cloud networking and to stay tuned for future developments in this dynamic field. Thank you all for joining us today, and this concludes our webinar.